The next session is on building your data core from identification to optimization. Tertius Rust will be leading that. He's the founder and executive director of the Innovation Consulting Company, and I'll ask him to come up in a moment to introduce his panel. After which, the technical masterclasses will be taking place. The masterclass on building AI-ready water utilities will be in the main plenary room. It will be led by Rubimbo Hakata from Aurora Tech in Zimbabwe. And then the technical masterclass on uncertainty to insight, practical foresight tools for the water sector, which will be led by Sahusta Jogwanth from Zutari, will be in the breakaway room. So a reminder, building AI-ready water utilities, that technical masterclass will happen in this room, and uncertainty to insight, practical foresight tools for the water sector, that masterclass will be happening in the breakaway room. All right, if I may ask that we start settling down so that I can introduce Tertius and for him to take the panel discussion away. I'm going to need to start calling out people by name, hey. Good sir, lovely top, sit down. The two gentlemen at the back in front of the camera. Ladies, do you mind indicating to those two gentlemen for me, please? If you guys can just settle down so that we can start with the panel discussion. Thank you very much. And I see some of them are starting to come in. Tertius, I suspect you'll have a lot of this where people are starting to move in as the session is underway. Please welcome the founder and executive director of the Innovation Consulting Company, Tertius Rust.
Good morning, everyone. I know there's still people outside making their way in. So today is we're going to talk about building your data core from identification to optimization. I'm very excited for this panel. We've got three diverse speakers, one from the municipality, actually living and breathing and needing to balance reactive work while also introducing innovation. Then we have the perspective of a founder looking into new ways of finding financial solutions in wastewater. And then we have the Earth observation data scientist looking at how geospatial information from satellites can all work together to improve decision making. Okay, so everyone knows that SMART starts with the data foundation, right? You're building your house on that core. So I'm going to introduce each of the panelists now, and they can make their way up, and then they're going to do a presentation, and then we have some questions afterwards. Okay, so I'm going to start with Deon Jager from George Municipality. He's the Deputy Director of Water Services, and he is going to talk about a project that they've done to build a digital twin using the data that they have. Next, Mpho. Yes. Okay, Mpho is from Digital Earth Africa. She's a data scientist, and I'm really excited to hear how satellites can also be used as a data input into our decision making. And then we have Moyo from WasteMoney. So Moyo is from Zimbabwe, and he is the one that is going to tell us how we can make money with waste. So, yes, thank you very much. Okay. So, first off, Moyo, do you want to do your presentation first, and then we'll go from there? Okay.
Good morning, everyone. My presentation, please. Is there a clicker? Great. Good morning, everyone. My name is Mpho Sadiki, and I'm from Digital Earth Africa. I'm a data scientist, specifically an Earth observation data scientist. And today I will be showing you how Earth observation can be used for water monitoring in Africa. So we're supporting smarter water decisions with open satellite data. So in a nutshell, Digital Earth Africa is a not-for-profit Pan-African organization that makes available satellite data, satellite products, services, as well as tools that enable decision-ready products tools on the continent. We hold the largest implementation of an open data cube in the world. Essentially, a data cube is just a nice structure of Earth observation data. If you've ever used satellite data before, you know how it's captured in scenes and it's all in time and space. So what a data cube does, it puts it in a nice little structure that it makes it easy for you to query through time and space. And of course, we have a continental scale service, which is completely free, even for commercial use. So if any of what I'll be talking about today is interesting to you, and you have a business, please reach out to us. We'll be happy to support you with that. Another important part about what we do at Digital Earth Africa is co-design. Everything we do is co-designed with our partners across the continent, so we are responding to the needs of the users on the continent, and we support this with an extensive library of tools and training materials and a dedicated capacity building program that can support you through workshops, trainings, should you require that. So I'm just going to highlight a few of the continental services that we have at Digital Earth Africa. When I speak of continental services, I'm talking about products that we create from the freely available satellite imagery that is available in the world. And when I say continental, I mean every single country in Africa, including the islands. And this is one of our very first products that we ever created, Water Observations from Space. It uses the Landsat archive, which goes back into the 80s in some parts of Africa. It goes back into 1984. And it identifies surface water across the entire continent. So this water, it gives you insights into surface water dynamics over 3-4 decades. It provides you with the continental coverage to identify patterns of water availability at local, regional, and country scale. And of course, you can do comparisons across the continent as well. So you identify persistent, seasonal, and rare water occurrences. So as I already mentioned, it uses the Landsat archive, which goes back into the 80s. There's an image every 16 days. So once that's available, we do create update this product. And of course, most importantly, you're able to detect long-term trends in surface water presence and variability. We then took this product, which tells you where water is at a point in time, and created what we call the Water Bodies Monitoring Service. So we identified over 700,000 unique water bodies across the continent. So these are actual vectors, like polygons of water bodies, and for each water body we determined the time series, so you're able to see how that water body has been changing since the 80s. And this is an operational service that we update every single week. So this could be useful to look at lakes, rivers, or not full rivers but segments of rivers, because we have a spatial resolution limitation, but also reservoirs and wetlands. So this is a very nice product that through our maps platform, you're able to get that time series without ever having to look at the satellite imagery. You don't have to know anything about remote sensing. Just click on a water body and you get that time series available to you. This is available through our easily accessible maps platform, which is a visualization platform. But also, if you need to do a little bit more, we do offer a cloud computing environment, which gives you access straight to our data cube, the 6 petabytes of data that we have available that you can then use to do further analysis. And this was demonstrated with this example that I won't really go into detail, but the International Water Management Institute is creating a digital twin for the Limpopo River Basin, and they were able to leverage information from that water body's monitoring service to then estimate changes in dam storage levels. So this is just something that you can also do within the Digital Earth Africa platform, and most importantly, it's open, it's free. If you're interested, reach out to us and we'll be able to help you. And just to end off, just to thank the people that make it possible for us to actually provide this lovely program openly and freely. Thank you.
Thank you. Thank you very much, Mpho. Okay, so next we're going to introduce, bring Moyo to the stage. He's going to talk about the great company that he's started.
Good morning, everyone. My name is Mthokozisi Mzingaye Moyo. I'm from WasteMoney Private Limited. I'm the director. I'm going to talk about closing the digital divide in Bulawayo. Background of the city of Bulawayo. It's been mentioned, I think, 3 times since yesterday that there's a point in time where we had 130-hour water shedding. This wasn't because of the municipality, but because of the climate conditions. The dams were quite low, so low that they'd reached the dead water level at 2.08%. That's below the intake works at the dams. So from a consumer's perspective and a municipality's perspective, most municipalities make their money from selling water. So you imagine you invest in the smart meters and you have a scenario like this. So you can't pay back your debt that debt you use to finance the smart meters. During that time, there happened to be the Wet Skills Challenge, which is a pressure cooker for young water professionals. And they were tasked with coming up with a civic engagement conceptual plan to relay the information to the residents that this is what's going on at the dams. So currently the city of Bulawayo has a dam watch dashboard that is in that format. From an engineering perspective, just a quick glance, you can see it was made by an engineer. It doesn't mean anything to the residents. It's percentages and stats. And what the residents want to know is, when is my water coming? That's what they're interested in. So we took up the challenges, WasteMoney and WasteSkills, and tried to look at the data that was available from the city of Bulawayo. We noticed that the city of Bulawayo has data, but it exists in fragmented silos. So there's data from the dams, the dam levels, the rainfall data. It's all coming in form of Excel sheets, and some are manual sheets. So everything exists, but then it's in separate compartments. You can't draw insights from that. So as we were planning to come up with the civic engagement tool, we noticed that there's a lot of smart tools that are coming on board, and then we decided to take a pause and have an overview look at how we want this dashboard to look like. So what this dashboard is basically going to do is, let's say there's a supplier of a smart meter. One of the requirements is that the smart meter should connect to this dashboard that is already existing, so that you don't have several dashboards from several individuals and companies that are having several, what you call them, the web interfaces, so you can't really draw insights from them. So we went to the foundation. We are getting that sorted out at the moment. And currently, from the data that exists, right, from the city of Bulawayo, we've managed to build this dashboard Outlook user interface. So these are the dams that currently supply the city of Bulawayo. So what then it means is that in Caesar dam, if it gets the smart meter, that becomes more of a reactive meter, while the other ones are still being fed by the Excel that exist. So we have a phased approach to how we're going to build the system. Instead of having a big tender, that will then scare away people. So we're taking a phased approach to that. And I use this image to really capture our lessons and observations as we're building this tool. The first one is the technical disconnect. The systems that we want to make smart are very archaic. They are old. So imagine strapping on a smart meter onto a very old pipe system. It doesn't solve the problem. I think it's been echoed several times here that technology is a tool, but it's not going to solve the problem. And then secondly, for other municipalities that want to take this journey, there's already some data that they've been collecting. So the onus is on them to get that data in some sort of a format that they can analyze. Let's start there. I feel this is the case for many African utilities, that you look at, let's say, the city of Cape Town. They are so far ahead that we feel discouraged by the amount of work that we have to do. But what we've learned with the city of Bulawayo is that there is some data that we can use to build. And then there's the cost barrier. Yesterday, in one of the discussions, in one of the roundtables, it was mentioned that these smart meters, there's also the issue of reliability. As Africa, which provider do we go with? And they're quite costly. So if it breaks down, to get them down here to come and look at it, that's another cost. And then the city of Bulawayo, you saw the 2%, right? There's a mindset that we need to build more dams and not address the inefficiencies. So we are also fighting with that. And we believe the data can actually show that you don't really need much dams, but you need to sort out the infrastructure first. And then finally, you need a dedicated team. It's a lot of work dealing with this data. And for many municipalities, I feel that the human resources required really need to be dedicated. So that's it from myself. Thank you.
Thank you very much, Moyo. So, yeah, we're making our journey from sensors to satellites, from dashboards to digital twins. So I wanted to bring Deon to the stage to talk a bit more about how they've did a digital twin in their water network.
Hi everyone, just testing. Deon the Jager. I'm the operational head of water services at the George Municipality, Deputy Director. Basically going to tell you about our journey into Katium, where it all started. You can see from the photo I presented earlier, I've gotten much grayer in the 4 years I've been working for the municipality. What a challenge and what a journey it's been. I think we're getting there, slowly but surely. I think we're making good progress. So yeah, let me tell you about our journey and how it went up until where we are at this stage. So, George Municipality, basically overview, situated in the Garden Route of the Western Cape, about 400 kilometers east from Cape Town. There are 225,000 residents. I think we're more or less 305,000 at this stage. We're the fastest growing town in South Africa. It's quite a climate sensitive region. You can expect all 4 seasons in one day, every day. Mountainous area next to the sea, got the Karoo on the other side of the mountain. So that's mainly a reason for the climate sensitivity. Then we also have a quite complex water network, mainly due to our topography. We've got multiple storage dams, raw water storage dams, 3 water treatment plants in George itself, 2 on the other side of the mountain. Then we've got multiple pump stations, about, I think, between 55 and 60 water pump stations, excluding boreholes, and about 43,000 connections in our network. So the digital transformation underway from reactive operations, digital twin, AMI, smart sensors, data-driven management. So how did we get to this point? So when I started my job at the municipality, in the first week when I arrived, I asked the guys, listen, we're flying blind, what's going on in the network? And if there wasn't any information like available so we can see what's happening in the water system, they brought me a piece of paper with 20 water meters that was manually read 10 years ago. So that's where we started. We basically replaced those meters with ultrasonic or magflow meters and connected it to our telemetry and SCADA systems so we can at least see what's happening in the network. And we basically rolled out the whole network in a phased approach where we installed additional bulk meters in the various zones so we can start monitoring the night flows, etc. in the network. But the problem was always, you've got various platforms that you basically working on. So you have to log into this platform, log into that platform. But you can never really consolidate the platforms and get all the information onto one platform and see one model that you can work with. And that was our challenge. And I think that is what's driven the process up until where we now. So digital momentum was already underway, as I've said. We had SCADA across our pumps, SCADA for our reservoirs, SCADA for our bulk water meters, etc. So the next step was full network visibility, as I've mentioned. So we had limited network visibility. We needed better day-to-day understanding of how the system operates to support operations in real time. So basically getting from reactive to proactive stage. Engineering capacity constraints. So we wanted hydraulic insight. It's imperative, especially with fewer engineering resources. Then strategic mandate. The IDP required smarter, more resilient, digital-enabled water management. That's one of the projects that was listed in the IDP for the George Municipality. And then protecting our AMI investment. With Sigfox meters rolling out, we needed to unlock full value from AMI and not just collect the data. You actually want to utilize the data and just not want data sitting there. And then shift to proactive operations. So move from reacting to failures and predicting and preventing network events. So you don't want to be in a situation where you run around in the field after leaking pipes and bursting pipe failures, etc. We want to know what's going on in our network, basically monitoring the network. So what did we expect to achieve? Model reality alignment, 75 to 80% accuracy. So obviously, the more hardware you install in field, the more accurate your model is going to be. Also, the calibration of the equipment is also of fundamental importance. We've picked up that there is some challenges with some of our existing meters in the network. The accuracy of it, and that basically compromises the model. So we also want to capture how we truly operate, so translate daily operational practices into a dynamic model. This requires deeply understanding how the network is actually run, and then a practical digital twin. So use the model not only for event responses, but for daily system operations planning and decision making. Better data, more data. Recognize that accurate modeling depends on accurate inputs. So expect it to improve data quality and expand sensor coverage where required. So that's also a challenge for us in terms of the sensor. I think Tertius can maybe talk about that later, or maybe explain about more on that. Get various communication platforms. So what we also experience in field is we basically running a testing regime where we can see that some of the instruments don't communicate that accurately than other instruments. So it's basically a trial and error exercise. Okay, then what didn't we expect? The complexity of moving a 168-hour simulation. So it's transitioning from steady state models to dynamic time simulation. So it was complex and time consuming. So at the end of the day, you don't want like just a model with nodes and pipes. You want a real life model that you can work with. I think that was always the idea from our side, is to get a real life model. So basically, if you isolate a certain portion of a network, you can see what happens to the network in terms of balancing. So that's also important for us. Sensor reality check. So many existing sensors were not operating at the accuracy of reliability levels required for digital twin that I've mentioned earlier. So we're working in that and trying to install additional pressure sensors and flow meters in our network on the bulk side. So obviously, as I've said earlier, the more hardware in your network, the more accurate your model will be. But at the end of the day, you must also remember that it's nice to install hardware in your network, but it needs to be managed. And you need to have that expertise in your organogram and in your organization to support the hardware and to look after the hardware. We get many fail alarms in our network, and that needs to be attended to immediately. Otherwise, you're just messing around with your water balance. You won't get accurate figures at the end of the year. Also, it's a legislative requirement at Water Affairs to report on your water balance quarterly. So we're trying to get our water balances as accurately as possible. AMI, instant model accuracy. So your daily AMI readings did not automatically improve digital twin calibration as expected. Field digital alignment is hard. So it's aligning what happens in the field with what is represented digitally proved more difficult than planned, as I've also mentioned earlier. Process change takes time. So shifting from outsourced modeling and risk-based operations to in-house use of CATIUM required deeper behavioral and process change than expected. So earlier I mentioned that one of the other presenters that it's difficult to basically present a shift or present a digital transformation to your colleagues or co-workers inside a municipality. They don't want to adapt, they don't want to change. So that behavioral change is important, and you need to really push hard to get that into place. Otherwise, it's just another model that's going to sit there. Okay. So what are we doing next? Test before we scale. Pilot and validate new technologies before committing long-term rollout decisions. So we are trial and testing some hardware in the network as we speak. Before you make this large investment, doesn't make sense if you install 60 million rands worth of meters and you're not sure what you're going to do with the meters and you're not sure the meters fit for purpose. So I can tell you a lot of things about meters, residential meters. Okay, sorry. Okay. Time out. Okay, sorry. Embedded the digital twin in daily operations, shift from modeling as a project tool to modeling as an operational system. Sorry, Tertius, I get excited. Strengthen data foundations, improve data quality, integration, governance, and ownership across all platforms. Then move from reactive to proactive management and operations. You don't want to react, you want to proact on the operational side. And then number 5, build internal capability. So you want to develop skills, workflows, and organizational structures to sustain smart water operations long term. Thank you.
Thank you very much, Deon. Yes, very interesting project. I'm very privileged that TICC is also involved with it, and GLS. So, please, if there's any questions, I'm going to ask a few questions, but raise your hand and then we can move the mic around. Moyo, you've now heard, you mentioned City of Cape Town as that beacon of light. George showing some interesting stuff as well. Deon did mention that it wasn't like this when they started. It's manual meter readings on a piece of paper. So if I could ask you, with your experience, where do you start? If there's a utility looking at City of Cape Town, George, what advice would you give them?
Okay, so from our end, we had to have a sit down with the City of Bulawayo and talk to the engineering teams and the operation teams and sort of pick their brains on what they wanted to achieve with the going smart or digital. And then from there, we then looked at the data they had, and then we started building from that. So it's very key, I think, to be open to listening to what they need and then incorporating what, instead of forcing down an idea down their throat. Yeah.
Thank you very much. Yes, I think the point also that even if you don't have a lot, you can still use it very effectively. Mpho, I think that's where this Earth observation and satellites comes in, which is very interesting because not a lot of people actually know that they have this massive data set that is at their disposal. So if you were to want to give some advice, where do you start? What is that single piece of information that you've seen that you provide through satellites? I like the Earth observation data. What a cool way of describing a new data stream, which people might not be aware of. So what would you say is that one data thing that you can really make a big difference into an organization like Utility?
In terms of, getting started with Earth observation, I also love that word. You don't need to reinvent the wheel. In fact, you don't need to go get an Earth observation, remote sensing, a GIS degree. If you have a problem and it's well defined, there's a lot already that exists from Earth observation data. Stuff that we are presenting here, we are creating a Digital Earth Africa. The space agencies also have a lot of work that they do. So first would be to just look at what is available, don't reinvent the wheel, use what's already there. But in case there isn't anything that exists, we exist. Digital Earth Africa exists for you. You come to us and we help you prototype, we help you define a use case, and we help you resolve your situation. And the whole idea is we're democratizing the use of Earth observation. You don't have to pay for it. There's a lot of satellite imagery that exists that unfortunately Africa is not capitalizing. So we're trying to make sure that you have that barrier to entry is removed and you have that access. So I think look at what is already available, but if you can't find what you need, reach out to organizations like Digital Earth Africa, space agencies, the CSIR. They would be able to help you with whatever you need in terms of leveraging Earth observation.
Great, thank you very much. I'm going to ask you another quick question, just because satellites are so interesting, right? Now, before we start building rockets and setting up our own satellites, what do you think is the on the horizon, which most people that doesn't work in the satellite Earth observation data, what is the thing that's in 2 to 5 years which you think will really be interesting technology that's coming through?
I think it's obviously, in our favorite word, artificial intelligence. We've already been using machine learning algorithms, deep learning algorithms, but right now we're seeing a major growth in foundation models. And with foundation models, what's really nice about them is they learn almost the general idea of what the Earth is, and you can almost adapt them to any scenario. You want to look at land use, land cover, you want to look at water changes. So that's for me, I think what's most exciting in the horizon. Foundation models, they're quick, they take in a lot of data, and if you include LLMs in there, you're able to then have that translation into more natural language that people can understand. You don't need to understand the Earth observation jargon. You can have it in your natural language and easily understand the outputs. So that's what I'd say.
Great, thank you very much. So we've made this journey from, I like the more hyper-awareness, right? What is happening? What data do you have? What sensors? What satellite imagery? And now you've kind of transitioned into a more decision, how to use AI to make better decisions. So Deon, I want to ask you, the next step is action, right? This is where moving from tools and people providing useful services for a utility, but how do you balance the day-to-day and then looking at exploiting or exploring? Like you have your day-to-day, there's no water, you need to respond, but you still need to keep your hand on that resilience in the future. How do you balance that?
That's a very good question. You can see my grey hairs here. So, to be honest, being in the field of operations is not easy. I have to be in the office like 100% of the time, but I'm not. I'm like 90% in the field. And that's what I like about my job. I like to be hands-on, work with the people on site, try and show them what's expected of them and set a standard, show them what set of skills are required for them to successfully execute the work on site, make sure, do the proper inspections, make sure that they know what to do. So it's quite tough to be in an operational field and obviously monitoring your network in field, but we do have protocols in place and instruments in place that can assist us, and we've got people or process controllers monitoring the dashboards and the digital side of things for us. If there's failures, we can react almost immediately. So during night, we've got shift systems where personnel sit and they're monitoring the system. So, and then obviously building on what we have, that's also, funding is always a problem, obviously. So going to council and basically motivating why we need additional funding to implement certain digital tools to assist us on the response side. So we can action faster response times if there's any events or failures in the network. So it's quite a bit of a challenge.
Yes, sounds like it. Thank you very much. So, yeah, setting the thresholds, alarm thresholds, not too low so you get overwhelmed with reactive stuff. Okay, any questions from the audience? We've got 1, 2. I think I'm going to straight out from the question. Anyone that's willing to answer it, let's do one at a time. So, Dr. Alexander Zinske.
Hello, Alex Zinske. I just got a question from Mpho. Have you ever looked into using satellite technology to assess water leakage? Obviously, you need higher resolution image probably, but there's definitely developments in that field, also using AI and machine learning to predict where a leak has been happening for an extended period.
I think, unfortunately, that's beyond our scope because we are not for profit. We don't buy data, so we're limited in terms of spatial resolution to the available Sentinel-2, which is at 10 meters, and at that resolution, you're not really going to be able to capture that kind of information. So unfortunately, we don't do that. But if you do have the commercial data and you just need the help setting up a workflow to do it, we'll be happy to help you and also offer you a cloud computing environment to do so.
Thank you very much. Question at the back.
Thanks. Maybe just a quick one. It's directed to Mzingaye, Mthokozisi. I think you did cite the issues that human resource required need to be dedicated, which predominantly indicates that there is a cultural dynamic that is taking place there. I'm just curious and interested, perhaps maybe we can learn from how did you deal with that resistance from the human resource? Perhaps maybe we can learn a thing or two. You know, when you're starting new things, it's always an issue when you have to break through that resistance. Thanks.
Okay, thank you for that. We were fortunate with the issue of timing. If you look at the crisis that was happening, it was forcing the leadership to look into other ways. Unfortunately, it then forces us to say that we have a reactionary kind of leadership. But then the timing also helped us because it made the leadership open to our solutions. So there's the issue of timing. And then, I'd like to blame, I think, timing. The crisis and the timing. Thanks.
Another question there?
Good day, colleagues. Siyabonga Sibeko. Just a quick question for George Municipality. When I was listening to Deon, I resonated with the presentation because it's practical. I also want to test the product before installing it in the field, rather than blowing up my 10 million, then later I'm holding my head. So basically, how many smart meters have installed for businesses, for your domestic customers? Yes, you did highlight the challenges, but like what are your daily challenges with now the new meters? And the one that we do not like to talk about is how do they behave where you have intermittent water supply and those type of things? Thanks.
We've got 1 minute. Sorry, open a can of worms. We've got 9,000 meters installed, smart water meters. We do have challenges regarding data and real-time data. I think we now in a situation where we actually want more data. So the more data we can have and the more frequent data we can have, the more accurate the CATIM model will be for us. So I think that's where we are at this stage. We're not going to elaborate on that now, but we are running some tests on alternative measuring devices. Thank you.
Okay, so we've got no more time left. So thank you very much, everyone. I'm just going to quickly wrap it up. So I found this conversation very exciting because you look at one observation is how can you just start, and then moving through the journey, through the steps, every year getting better and better, looking at data that is already available for you to be used and make better decisions, and then looking at potentially, if you scale, what is the risk and the concerns about actually operationalizing it? What is the sensor anomaly detection that you need to do if there's any drift or floats or errors with your data? How do you use that, and how do you change your people to actually use the tools that you provide in a smart way? Yes, so for that, I'm going to bring this session to a close. Thank you very much for everyone, and please give a hand of applause to Luca.